So matrix A is given, matrix D is a diagonal matrix with diagonal entries 3, 0, 2, and -1, and we need to find their products DA and AD. So we can write down that matrix D equals, here we have 3, 0, 2, -1, and the rest of the entries are zeros. Here our matrix D. Well, since A is 4×4 matrix and D is 4×4 matrix as well, that means that both DA and AD exist. So let's start by finding DA. So DA equals matrix D times matrix A So here we get the first entry is the dot product of the first row of matrix D and first column of matrix A. So it's 3 times 2i, so 6i, plus 0 times 0, plus 0 times next -I, plus 0 times 1, so 0. Next is 3 times 0, plus 0 times 1, plus I, plus 0 times 1, plus 0 times 1, so it's 0. Next, it's 3 times 1 and then plus 0. And next we have 3 times 3i plus 0, so 9i. Well, in the next row, so the next row of matrix D is all zeros. So it means that the dot product of this row with the columns of matrix A will be equal 0. So here we get all zeros. In the next row, we have 0 times 2i plus 0 times 0 plus 2 times -I, so -2i plus 0 times 1. Next, it's 0 times 0 plus 0 times 1 plus I plus 2 times 1, so it's 2 plus 0. Next, it's 0 times 1 plus 0 times 8 plus 2 times 0 plus 0 times 1, so 0. And here we get 0 times 3i plus 0 times 0 plus 2 times I, so 2i, plus 0 times 1. Well, and in our last row, we get 0 plus 0 plus 0 plus -1, then 0 plus -1, -1, -1. So all entries of the last row are -1. Well, now let's find matrix AD. So matrix AD equals matrix A times matrix D and this equals, so here we get 2i times 3, which is 6i, then plus 0, because all other entries of the first column of the second matrix are zeros. Then here we get 0, then next we get 2i times 0 plus 0 times 0 plus 1 times 2 plus 3i times 0, so it's 2. And next we get 2i times 0, 0 times 0, 1 plus 0, 1 times 0, and 3i times -1, so -3i. In the next row, it's 0, then 0, then 16, then 0, -3i, 0, 0, -I, 3, 0, 2, -1. So this is matrix AD.